is a platform for real-time communication. It's an open platform. Uh, basically, my talk today will be centered around the components of WebRTC, and I'll show you some basic demos and also the code to those demos so that you can see how simple it is to actually implement WebRTC. And it's actually a nascent project, and so I'll just show you how you can go about and actually start using WebRTC for your applications or your products. So a bit about myself. I'm a CS student in my final year. So I'm also a Mozilla developer with L1 access, and I'm a Mozilla student rep. So actually, it was at Mozilla that I got involved in WebRTC. And basically, I'm also an open source enthusiast, and my interests are mostly web technologies, AI, ML, and networks. So the story behind WebRTC. Initially, Google Hangouts was founded by a guy named Justin Uberti. He's the tech lead on the team. And Google came up with this idea that you need an open platform for real-time communication. So they wanted to make multimedia as available as data is today on the browser. So that's how the motivation behind WebRTC was found. So okay, the basic aim of WebRTC is to make real-time communication go hand in hand with the web. So it's all done through a simple JS API. You'll see how simple the API is actually. There's not much to it, but there's a lot of heavy pulling going on behind the API. So you can achieve audio or video communication through the browser in simple terms. So you have access to all kinds of media, and you can do this even parallelly through the browser. And so the vision of WebRTC is to shift the communications industry to the web. So all kinds of communication can be done through the web platform. So it basically eliminates the use of SIP, but it's not out yet. So RTC feature can be easily enabled in all apps. So imagine you just have some service app or something. So you can have service support which has a video element. You can talk live with the people involved in who are supporting the product or something. And it's as easy as loading a web page once you know how to do it. So it's a common platform for real-time communication. And now I'll go into the components of WebRTC. So it has three basic components, and so the first component is called media streams. This acquires all your media from the camera, mic, and you can also send in audio data, but that's not in yet. The present version of Firefox, the developer version, the alpha version, has media streams and peer connections, and data channels is not properly experimented with yet. So peer connection allows you to make a peer-to-peer connection between the browsers. So it's like a decentralized network. And the next part is data channels. That's like my favorite part, because data channels is like you can exchange data peer-to-peer with any browser. You can just connect to someone, and the data is all transferred peer-to-peer. So the first part, the media streams, is handled by a function called GetUserMedia. So actually, GetUserMedia problem with the cable. I can see. Okay. So you can get multiple tracks through the GetUserMedia function. So each track can have multiple channels. What I mean by this is, suppose you have an audio and video track. Those are called the multiple tracks. So through a media stream, you can get the audio and video at the same time. And then you have multiple channels. So one audio, you can split the data into multiple channels and send it over. That makes it much faster, and that makes it a real-time application, because the ability to create multiple channels for each track is what is unique about WebRTC. Then the GetUserMedia is also nicknamed as GUM. The GUM API acquires the media stream from the camera or mic. So you can actually have a video chat application, not a video chat, at least there's actually a face recognition application which has been developed just using GetUserMedia and some background JavaScript code. You can actually check it out on the Google code, I guess, Google code for WebRTC. And so this integrates well with audio and video elements of the HTML5 code. So you can do whatever you want with it. So I'm going to show you a demo of GUM. Okay. So this is the GUM test page. First, we'll check out the video. Is it? So you get the, I don't know. So you get all the video input on your browser. You don't have any background app running. You just, it's all through the browser. And I think you can get audio and video as well. So you can hear what I'm saying, right? So you can hear what I'm saying.
Can you shut off the audio?
Yeah. So that was about the GUM demo. And so what is peer connection? It's actually a high-level API which enables you to easily connect peer-to-peer with any browser. And it has everything built in. So you don't have to worry about most of the parts like security and bandwidth management and all. And so all the encryption, peer-to-peer channel for audio, video, codec control, bandwidth management, everything is done inside the browser. You just have to use the API. That's it. So how is the peer-to-peer session set up? There's a process called signaling. Though it's not as easy as it looks, the concept behind it is pretty easy. Like first a caller sends an offer, then the callee receives an offer, callee sends an answer, and the caller receives the answer. It's as simple as that. But the heavy pulling is done behind. It's all signaling C++ code, and you don't have to worry about it. All you have to worry about is these 4 steps, and you can establish a peer-to-peer connection. So more about the peer-to-peer connection. So it's done through a mechanism called ICE. So ICE handles all the signaling code inside WebRTC. And so ICE has something called a local description and a remote description. So suppose a caller makes a call. You have a local description about the call which is generated. Then you send over the local description to the callee. And the callee has the remote description. So based on the remote description, it generates its own local description and sends it back to the caller. So basically, what's taking place is a session description protocol called SDP. So you establish a session between the 2 peers. So the architecture for this peer-to-peer channel is called JSEP. JSEP stands for JavaScript Session Establishment Protocol. So it's exactly as I described, right? The caller sends a signal and the callee receives the signal. And then the callee sends back an answer and the browser receives the answer. What you notice here is that the two apps are not connected, like what happens in Skype and all. The two browsers are connected directly, and once the session description is got, the media is exchanged between the browsers. You no longer need the inbuilt add-on or app inside the browser. So it's a direct connection between the browser and it's peer-to-peer, so it's real fast. So I'll show you a demo of peer connection. So this is peer connection on the same tab, so it's like cheating or something, but but you don't have the nightly, right? Oh, okay. But it might have the same issues, right? So the slides, should I get it? Let's hope the demo works. So you just go click on start, and it should work. Yeah. So this is my my video. So this is my video going in. Oh, that's his. Okay, so this is my video input, and it's getting reflected on the other end. Which, we put it on the same tab because it's a test file. So that's about it. It establishes all this through JSEP. You don't need anything else. So, is it in duplicate? No, should I check? It is. Just click on from current slide.
Okay, whose brilliant idea was it to put a little button over there? Yes.
Left. Okay. So now to data channels. So I don't have a working demo on data channels because it's like so new that no one's actually developed anything on it. Data channels is basically like WebSockets. It's two-way, but it's peer-to-peer. The advantages are low latency, high measure rate throughput, and this is the best part. You can have reliable or unreliable semantics, and it's totally up to the developer who's using the API. So some use cases about data channels. You can use it for gaming applications. Suppose you have a chess game. You can actually integrate it with WebGL. So you have a 3D view of a chessboard, and on the opposite side, you actually can see the other person. So remote desktop applications. We don't need another app for remote desktop applications. You can directly go watch a webcast, share the desktop. Everything can be done through the browser. And I think the next one is real-time text. Real-time text is, as you're typing, the text gets displayed to the other peer. So this is like actually talking to someone through texting. File sharing. You're actually making a torrent on your browser. You don't need a torrent application. So it has a lot of security concerns, but that's like a torrent on your browser. And you get truly decentralized networks. Obviously, it's peer-to-peer, and it has no central server handling all the requests, right? So DC leverages on peer connection. What I mean by this is that you first establish a peer connection to actually work on the data channels code. So you first establish the peer connection, then the DC connection, and send data over it. You can create multiple channels here as well. And as I mentioned, there's also the option for prioritizing a channel. So you can have priority for one channel over the other if you're using multiple connections. And there's inbuilt DTLS and congestion control. And you can do it with or without audio. So it's totally dependent on the application you're developing. And it's similar to the WebSockets API. So it's easy for someone who's used WebSockets to actually adopt the data channels API. So I can show you a sample code of data channels. There's only 10 minutes, right? I'll finish it first. No, get it back to the... Okay, I'll show you the code later because I'm running out of time. So what's the ongoing work on this area? So basically, integration with audio data API is coming soon. So audio data API is something like you can access all the attributes of an audio, and you can access the data within the audio, change it, manipulate it, and send it over the network. And a usable version of data channels will be out with the next Firefox, and they're planning to fix everything. Right now, you have to go to preferences and set these to true, even in the alpha testing version. So they're planning to put it by default, and so you can probably, if you have the alpha test version for the next Firefox, you can actually start working on data channels. And so they're also building new innovative and cool demos and apps. This is an interesting place to be in because it's still a young project and everyone's welcome to contribute to it. So WebRTC support is on all browsers, Firefox, Chrome, Opera, and IE. On IE, it's through the Chrome framework, actually. And there's also a native C++ version for WebRTC for IE. OK, so what all this means? There's a rich image and video apps on mobile browsers. And actually, OK, there's one use case, which is that citizen journalist can actually stream live video directly to your TVs and all that. And you can give live support and feedback. And there are actually new challenges to government censorship. So you can do effortless file distribution. The impact of WebRTC. OK, so sharing should be as simple as loading a web page. That's the basic bottom line of WebRTC. And this will obviously facilitate a new way of development, and students can get involved in projects, and it'll change the way we live, work, and play, obviously. So really, get excited about this project. Try to get involved. And this is a quote. So potentially, what it actually means is that the browser is going to transform media like it originally did for data. And this is the transition of the web since the first reckoning through HTTP. So first there was HTTP, then AJAX, then WebSockets, and WebRTC is the new revolution coming now. And so you can be part of this revolution. You can start contributing. And it's as simple. We need you, and you can actually work for a better web. Everyone can contribute, developers, designers, and even people who use it. Just download the alpha test version of Firefox or try WebRTC on Chrome, report bugs. We can fix it. We can go faster with the project. And if you want to know more, these are the links. I'll put up these on the SlideShare website and on a funnel. And thank you. So, do you have any questions? And you can go to the IRC for any.
Have some time for questions.
Hey, so have you seen this Chrome remoting? So does it use the same protocol?
Ooh, sorry. Yeah.
This is Varun.
Okay.
Actually, my question is, so Chrome introduced something called Chrome remoting, right? Wherein you can share your desktop with somebody else running Chrome. So
yeah, but actually, they're planning to do it on WebRTC because it's easier and faster, and it won't have any lags. But the problem with WebRTC is the data channels API is not out yet, so they tried that first. Chrome doesn't even have a beginning version of
what
data
is the protocol, underlying protocol behind that?
Basically,
Chrome?
it's JSEP, which I described. It's the JavaScript establishment protocol. And there's also SDP, which gives the session descriptions. And there's a framework called ICE that does all the signaling and heavy pulling behind the scenes.
Thank you.
Hello. I have just a question about the security of this thing. Like, if
Yeah,
I go to a
actually-
random website and they start recording my video or something.
Yeah, exactly. There's a issue on security, and actually there's a working group, W3C group, about WebRTC. They set the standards, so they have all the specs and all going on. And yeah, security is being worked on by a specific set of people.
Like in Flash, if you try to access a webcam, there will be a allow deny access.
The other problem is you can like directly pirate anything, right?
But is there any like allow deny permission thing in WebRTC now?
Yeah, actually the data channels is the problem. I think GetUserMedia has pretty good security, but data channels, even the API is not out properly. So once the API is out, they'll start looking at the security.